Hello learners, and welcome to another presentation of a lesson in mathematics. I am Makubalo Frederick, and our topic of discussion in general is probability. Specifically, we are going to look at tree diagrams. Therefore, at the end of this lesson, you should be able to construct tree diagrams and be able to use the tree diagrams to solve problems in probability. At this point in time, let's move on and look at the basic features of a tree diagram before we get to construct one. When a tree diagram is constructed, you are going to have nodes, out of which there will be one which is the starting node, and it is referred to as the root node. Then you are going to have what are known as sub nodes. So you are going to have nodes which are divided into the starting node, referred to as the root node. Then there will be some other nodes which I would like us to refer to as the sub nodes. The other feature about tree diagrams is the feature of branches. So you are going to have branches coming from the nodes. And what happens is the number of branches coming from a particular node will be equal to the total number of different possible outcomes. So, like I said, in a tree diagram, we are going to have the branches, and these branches are going to be coming from the nodes, which will either be the root node or the sub nodes. And the total number of branches from a particular node is going to be equal to the total number of possible outcomes. And the other thing is, you need to have the outcomes for any particular branch written at the end of the branches. So outcomes are indicated at the end of the branches. And on these branches, there will be need for you to indicate the probabilities for the outcomes that are indicated at the end of each one of them. So probabilities are indicated on the branches. So basically, these are the main features, and what you are going to see is the tree diagram is going to have phases or stages, and the number of phases or stages will be equal to the number of events that are going to be performed. So the last point to take note of is that number stages that are going to be in the tree diagram must be equal to the number of events that are going to be performed. So, having looked at these features, I want us to proceed and look at an example and get to see how we can construct a tree diagram. Marbles are in a box. 2 are picked at random, one after the other, without replacement. Note that there is no replacement. The first thing we are required to do is to construct a tree diagram which must be able to show all the possible combinations of the 2 is the root node. So we are going to have this node as the root node, and from this root node we are going to have branches. I indicated that the number of branches must be equal to the total number of different possible outcomes. When we look at our question, we have red marbles, black marbles, and white marbles. So we have 3 different possible outcomes, meaning from our root node we are going to have 3 branches. 1, 2, 3. Each one of them representing the different outcomes that are there. And these outcomes, I said, must be indicated at the end of the branches. So we have a branch for the outcome red. I'm going to use capital letter R to denote red. Then we have another root for the outcome black. I'll use capital letter B. And we have another one for white. So I'll use capital letter W for white. This is the first stage representing the picking of the first marble. And I said, on these branches, we must be able to indicate the probabilities leading to each one of these outcomes. So let's start with the first one, which is red. What is the probability of having a red marble given this situation? When we look at our information, we have 4 red marbles, 5 black, and 6 white, giving us a total of 15 marbles. So the total number of possible outcomes is 15, out of which the red ones are 4. So on this branch, we are going to indicate 4 out of 15 as the probability of picking a red marble when the first one is done. We come to the other outcome, which is black, and we know we have 5 of them. So on this branch, we indicate 5 over 15. And lastly, we go to the branch for the white outcome, and we know we have 6 of them. So we are going to have 6 out of 15. This we must even indicate to say it is the first stage, meaning the first marble has been picked. But remember, we must pick 2, meaning we are going to have 2 stages. So let's move on. we have three different possibilities. The first possibility is having the first marble as red. When the first one is red, a second one will be picked, and meaning we are going to have a sub-node at this point. This second marble will either be red, black, or white. And those outcomes must be indicated respectively. Red, black, white. But there is also a possibility that the first one is not actually red, but black. If the first one is black, there will be need for us to go back to this box and pick a second one, which will either be red, black, or white. So, like in the previous case, these outcomes are going to be indicated at the end of the branches. And we also have a possibility that the first one could have actually been white. If it is white, there will be need for us to pick the second one, which will either be red, black, or white. So we indicate the outcomes accordingly. Having done this, we even need to indicate that this is the picking of the second marble. And on the branches, remember, we must be able to indicate their respective probabilities. It is this second stage where we need to be very careful, because a number of confusions may arise if you are not careful. So, let's move on. Let's start with this one. This is on the assumption that the first marble picked is red. And remember, there is no replacement. So the total number of marbles would have reduced from 15 to 14, meaning the denominator for this probability must be 14. What will be the numerator? We look back. Which one was the first marble picked? It was red. Initially, the red ones are 4, meaning when one is removed, they will remain to be 3. So the numerator there is going to be 3. So the probability of picking a red marble after a red marble has been picked is going to be 3 over 14. We also need to do the same for the other two. So, on the assumption that the first one is red, it means the black ones are still intact. They have not been touched. So, they are still 5. Out of the remaining 14 marbles. And the same reasoning will be extended to this one. The first one was red. For us to pick a white one, it means the white ones are still 6 out of the remaining 14. So that is how the probabilities are going to come out. But like we said, there is also a possibility that the first one is actually not red but black. So if it is black and we want a red one, it means the red ones are still intact. They are 4. The one which has been picked is a black one. So to find the probability of picking a red one after a black one, we will say the red ones are still 4, but the total number would have reduced from 15 to 14. Please bear in mind that we are not saying 2 marbles have been removed because first it was red then black. We are taking different assumptions. The first one was the assumption that the first is red. Now we are taking the assumption that the first one to be picked is actually black. So if the first one is black, it means the black ones would have reduced from 5 to 4. And the total number of marbles will be 14. So black after black will be 4 over 14. Then of course, the 6 white marbles will still be intact, meaning the probability of picking a white marble after a black marble will be 6 over 14. The same reasoning will be extended to this other possibility where we are going to say the first one was actually white and not black nor red. I'll give you a few seconds before I indicate the probabilities on these branches for you to work out like the way I have worked out on the first two for the second picking. I hope you have managed to get the answers that I'm going to indicate. And let's do it together. This is on the assumption that the first one is white, meaning the red ones have not been affected. They are still 4. So we are going to have 4 out of 14 because 1 has been removed. If the first one is white, the black ones are still 5. So here the probability is going to be 5 over 14. And now, if the first one is white, it means the total number of white marbles would have reduced from 6 to 5, and the probability will come out as 5 over 15. It's only 2 marbles that have been picked. If it were 3, we could have gone on with the extension of the tree diagram. So having done this, it's a question of now writing down the outcomes. This is having a red marble followed by another red marble. This is the result of having a red marble followed by a black one. This is red followed by white. This is a combination of black followed by red. And in this case, we have a combination of black followed by black. Then we have black followed by white. In this case, it is white followed by red. Then we have white followed by black. And finally, this is a combination of white followed by white. So, having constructed this tree diagram, we can now use it to answer the questions that have been asked. I'm going to read through them so that as we answer them, we refer to the tree diagram. Find the probability that part A, the first marble is red and the second one is black. Part B, one marble is red and the other one is black. Please mark the statements clearly because sometimes the language might be confusing, so we have to be very clear. Part C, both marbles are white. Part D, both marbles are of the same color. Then lastly, on our example, at least one of the marbles is black. So we'll get to see how we use our tree diagram to answer these questions. Part A requires us to find the probability of having the first marble as red and the second one as black. So all we need to do is to go to our tree diagram and scan through these combinations and identify all the situations that are going to satisfy the condition given. If you nicely scan through, you are going to see that the combination that satisfies the condition given is this one here, where we are told the first one is red and the second one is black. So in answering this one, we will proceed as follows. Part A, P for probability. Then in the brackets, we indicate the given condition. So the condition is red, then black. Which is equal to, then we move from the root node up to this condition satisfying what we have been given. As we move, we are going to move through the probability 4 over 15 and 5 over 14, meaning the answer will be the product of the two probabilities that we have moved through. So 4 over 15 and, implying multiplication, 5 over 14. Then having done this, it will be a question of us simplifying as follows. We know when fractions are multiplied, you multiply numerator by numerator divided by the product of the denominator by the denominator. And at this stage, you need to simplify where possible. Like we can see that we do have a common factor of 5 in both the numerator and the denominator. So we divide by 5, we get 1. We also divide by 5 to get 3. We can see that we also have a common factor of 2 when we look at 4 and 14. So we divide by 2, we get 2. And when we divide by 2, we are going to have 7. Then we proceed and have 2 multiplied by 1, which is 2, divided by 3 multiplied by 7, which will give us 21. So this is going to come out as the probability of having a red marble followed by a black marble. Let's move on now to part B, where we are told one marble is red and the other one is black. So in this case, the order is not very important. It's a question of having a red and a black marble. So when we scan through these outcomes, we are going to see that this is a combination of red and black. This is also another combination of red and black. So for us to have red and black, we are going to take either this root or this root. And remember, the word "or" in mathematics, in as far as probabilities are concerned, is associated with addition of probabilities. So our presentation will be as follows. P for probability, red and black. And like I said, the order is not very important, meaning we have two possible combinations. It's either you have the probability of red followed by black, or the probability of black followed by red. When we look at our tree diagram, red followed by black is as a result of 4 over 15 and 5 over 14. So we are going to have 4 over 15 and, which signifies multiplication, 5 over 14. The word or, like I said, signifies addition. And for us to have this combination of black followed by red, it is 5 over 15 and 4 over 14. So we are going to have 5 over 15 and 4 over 14. You will recall that this is actually what we found in part A. And the answer in part A came out to be 2 over 21 plus. We need just to work this one out. And like I said, multiplication is numerator by numerator divided by denominator by denominator. And we get to simplify. 5 divided by 5 is 1. 15 divided by 5 is 3. 4 divided by 2 is 2. 14 divided by 2 is 7. When we proceed, we are going to have 2 over 21 plus 1 times 2, which is 2 over 3 times 7, which is 21. Then the two fractions are going to be added, the lowest common denominator being 21. 21 into 21 is 1. Multiplied by 2, we get 2 plus. Like in the previous case, this is also going to be 2. Upon addition in the numerator, the answer is going to be 4 over 21. So this is going to be the probability of having a black and a red marble without considering the order. Part C of our example requires us to find the probability that both marbles are white. From what we have done so far, I strongly believe that that is a very simple one. And the same applies to part D, which talks about having the probability of the two marbles being of the same color. Probably we should take time to look at the last part, which talks about at least one of the marbles is black. And remember, the term at least means a minimum of. So we are saying a minimum of one marble must be black. So we will go to our tree diagram, scan through and pick out all those combinations where at least one marble is black. So when we do that, we are going to see that this is a combination where one marble at least is black. This one also is where one of the marbles is black. Even where there are two, it means at least one marble is black. Then this combination also talks about at least one of them is black. And of course, this one here. So like we did, as we move from the root to the end, we multiply the probabilities. But as we combine these alternative combinations, we do addition. So our presentation will be as follows. So this is part E, probability at least one black. And the possible combinations as identified earlier on are the probability red-black, or the probability black-red, or the probability black-black, or the probability black-white, or the probability of having white and black. When you look at what we have so far, we are going to appreciate that the first two, we have already found them as we were answering part A and part B. This is the one which talks about the first one is red, the second one is black, and we found this probability to be 2 over 21 plus. When you refer to our workings for part B, we also found the probability of the first one being black followed by red as 2 over 21 plus. The last three are the ones that have not yet been worked out. But when we follow through our tree diagram, we are going to see that black followed by black is 5 over 15